Hello everyone, welcome to my channel. Let's look at the 13th day problem. Here we have the problem of metric script. Let's look at the problem we need to do. Neo has a complex script. The matrix script is n cross m. So this is going to be n cross m, n rows and m columns, and consists of alphanumeric characters, spaces and symbols. So it consists of alphanumeric characters, then symbols and spaces too. So they have demonstrated here, this is the matrix and this is the decoded form of the matrix. This percentage symbol hash is like that. So let's see what we need to do. To decode the script, Neo needs to read each columns and select only alphanumeric characters and then connect them. So he has to read each column and connect alphanumeric characters. Neo reads the column from top to bottom and starts reading from leftmost column. So he has to read from top to bottom, then like this. So this starts from here, then goes top of here and goes down, then down. This way he has to read the matrix. If there are symbols or spaces between alphanumeric characters of the decoded script, then Neo replaces them with single spaces for better readability. So if there are symbols or spaces between two alphanumeric characters, he has to replace it with a single space. That's some cleaning part we need to do. Neo feels that there is no need to use if conditions for decoding. So we are not allowed to use if conditions. We can use, but he says there is no need to use. Okay, so we also don't use that. Then alphanumeric character consists of, they have provided us like A to Z, cap uppercase, then A to Z lowercase, then 0 to 9. These are the alphanumeric characters. Then input format. First line contains space separated integers, n rows and m columns, as we said earlier. So here we have 7 rows and 3 columns. So here will be 1 2 3 4 5 6 7 and 3 columns, TSI. So these are the 3 columns. I can't select them. So then the output format, print the decoded matrix script. That's the output format. So this is the output format they have provided over here. Let's see explanation. Neo replaces the symbols or spaces between alphanumeric characters with single spaces for readability. The final decoded script is this. So this is the original script that is decoded from the matrix, and when we process the cleaning part, we will get this output. So that the non-alphanumeric characters, that this dollar symbol and hash gets replaced with a space. Then similarly this percentage gets removed with a space, and here it remains as it is. So like it's not between two alphanumeric characters, as we only need to remove if the symbols or spaces are between two alphanumeric characters, we need it to be removed and replaced it with space. So if they lie together, we don't need to do anything. So only if these symbols are between two alphanumeric characters, here S and I, so these two symbols was between these two letters, so that's why we need to remove it. Okay, now they have provided us some codes. So first, in multiple input equal to input dot rstrip dot split. So they have taken this part they have already taken, so it will become a string. Oh, they have splitted it, so it will become a list. Rstrip means they will strip out the empty spaced part, and this will convert to a list with 2 elements. So n will be the first element and m will be the second element. So next part, they have declared a empty list, and in that list they are checking for looping through n and adding the elements to the m and making a matrix. So let's print it out. Print matrix. So they have provided us over here. So this is what we got. Like each of this is converted to a element of this list. That's what happened over here. So now we need to get the first element, all the elements in zeroth indices of each element. So this is the first element, second element, third element, fourth element, like that. So we need to get zeroth index of each element combined, first element of each element combined, second indices of each element combined. So that's what we need to get. Thus we can get the decoded form. So let's, this is like over, we don't need to do like that. Just minimize the code, let it be a, so that we can just write a over here. Similarly this also will be converted to a, and here also there is no need to mention another variable like matrix item equal to input. We can just use the same thing over here. They are just used an x some, okay. We'll get the same output, so we don't need to do all those part. Okay, let's clean it a little bit. Okay, now in order to convert this matrix to this decoded form, there are actually two ways we can do that. So let me show the first method. It's tricky, but we have to be aware of that. So there are, when we actually print out the list, there are actually 7 elements in it. 1 2 3 4 5 6 7. 7 elements are already present in that, and we need to get each element. There are 3 letters in it. Letters means 3 of the characters, whether it's alphanumeric or symbols, whatever, like 3 characters are present in each element. So we have to actually combine the zeroth indices of each of the element together. So in order to do that, first we have to loop through m, so that for I in range of m, then we have to loop through range of n, and we can define a decoded string. Decoded string equal to, okay, now that part is done. Now what we need to do is decoded string equal to decoded string plus matrix of j of I. So what the code does is, let me explain first. So here we have for I in m. So m, there are totally 3 m. Let's see this, let me explain with this example. So here m is 3 actually. So when these loops work, m starts from 0 and it goes up to 2. Totally there will be 3 loops, like 0, 1 and 2. Similarly for n case, here 7, so it starts from 0 and goes till 6. So when these loops work for the first time, I value will be 0. So I equal to 0 here, and at that time j equal to 0, and it continues till 6. J starts with 0 first, then 1 2 3, like that till 6 it goes on. That's what happening. Only after when j starts from 0 to 6, then only the I changes to 1. So here it goes from 0 to 6. So that's what gonna happen here. So when we do like decoder string equal to decoded string plus matrix of this thing, like here plus equal to means decoded string equal to decoded string plus, like it's just a short form if you guys don't know. So here matrix of j, so j is gonna be 0 for the first time. So 0, then I equal to 0. I will be 0 till j starts from 0 and goes till 6. So each for starting from this 0th term to 6th term, like totally there will be 7 elements, right? 0 1 2 3 4 5 6. So starting from 0th element to the 6th element, the 0th indices will get added to the decoded string, so that each of the first element gets added to the string when this starts from 0 and ends till 6th term. And for the next time when this is completed, I value changes to I equal to 1. When I equal to 1, again j starts from j equal to 0 to 6. So when the next loop goes from the 0 to 6th term, each of the first indices will be added to the decoded element. So in this case, like if you are considering a matrix, all the first column gets added first, then all the second column gets added second, all the third columns will get added third, like that. So that's what gonna happen here. If I am writing this way, like for this term, j will be 0 first, then I will be 0. I will be always 0 throughout this 0 to 6. So it keep changes from 1 to till 6. And in this case I will be always 1, and j starts from 0 and goes on till 6. And in the next, when the next iteration comes, I equal to 2, and j starts from 0 to n. So that's what happening here. Let's print the decoded string. Let's run the code. So we finally got the decoded matrix format. This is the decoded format, and we need to convert this one to this thing. Okay, there is actually another method we can do. We can use the zip function in order to do the same process, like just convert it to and use the zip function, like a print of zip of matrix. What zip function actually does is that it combines all the elements in the same indices together. If there is two list inside a zip function, each of the indices that are on the same position, like the 0th index of the two list will be added together, first indices of the two lists will be added together, and each of them will be converted to a tuple, like that. So here when we run the code, it's an object, so we need to make it a list. Okay, then only it will show list. Okay, let's see it now. Okay, now it's in the same format itself as when we combined, not combined, in the matrix form. Each of them was inside a tuple. Okay, so we need to get out of the list, like it was inside a list, and inside the list each element was this was an element, this much was an element, this was an element, this was an element. So it was already inside a list, so we need to get out of that list, then only we can make the zip function work. So we can use a star over there. So let's see what we got. Let's print the decoded statement too, so that it will be clear for us. Okay. Oh, okay, sorry, I forgot to do this part. Let it be like that. Let's print the matrix. Now let's run the code. Okay, here we have, when the zip function works, it combines all the indices present in the 0th index. So here T, H, I, S, everything in the first means 0th indices of each element gets added to a single tuple. So they are added to a single tuple, and next this second indices will be added to a tuple, and the third indices will be added to a tuple. So we only need to do is like combine these tuples together and then combine everything together. That's all we need to do. So we can loop through this matrix and do that part. So let's remove that and find zip of function. And we need the decoded string, right? It's already we have denoted over here. So we need to combine I means this term, this tuple will be I, so we need to join that I, then only we can do get the decoded string. So decoded string equal to dot join of I. Then let's print it out. So it will combine I and it gets added to decoded string each time. So when the loop runs for the first time, this term gets combined and added to the decoded list, and then next this term gets combined and added to the list, like that. So let's run the code. Okay, if we got the decoded output, so that part is done. So let's use the simplest format. Yeah, let it be there. Okay, whatever. So now we have the task to convert this decoded format to this format. In order to do that, there are actually like two methods for doing that too. Either we can find the pattern that is between two alphanumeric characters and remove that with space, or we can find the characters, alphanumeric characters, and subtract that from the remaining characters. Like, one thing is that we can directly find this one, this term, and yeah, okay, that much only, right? Yeah, this term and then this term, and convert it to space. Other thing is that we can find the things that are not alphanumeric character, so it will eventually lead to this one itself. So first we can do for the direct approach. In order to do that, first we have to make the pattern. So pattern is equal to array dot compile of then here there is always like alphanumeric character is present, then in between that there will be non alphanumeric characters, and then there will be alphanumeric character. So in order to get that, we can, let's define 3 over here. So in the first part it will be an alphanumeric character, so there is actually expression characters over here. W /W returns a match which contains strings and words, characters from A to Z, digits from 0 to 9, and an underscore character. So we can use this one. So W for the alphanumeric character, similar W for the alphanumeric character, and in between that we need non-alphanumeric character, right? Something that is not alphanumeric. So here capital W is present over there. It returns a match where the string does not contain any words, any word character. So it means it will print all the non-alphanumeric characters, symbols like that. So we can use that over here, capital W, and we need to find more than a single character. So we need to add a +2, plus sign 2. Then what we can do is that there is actually a method in regular expression objects to substitute for a pattern. Suppose we have a pattern, we need to change that particular pattern to something else. We can use something over here. The sub method replaces one or many matches with a string. So let's click it. So let's try it out. So here replaces all white spaces with digit 9. So this is the text over here, the rain in Spain. So this /s, like /s, finds the white spaces. Let me show you over here. Yeah, returns matches where the string contains a white space. So it will find all the white spaces, and in place of the white space it will replace with the string 9. So If we increase the space, then run the code, it will print all the spaces with a 9. So that's gonna happen. So it will be like pattern, then the text that's gonna be replaced with the for the pattern, and the text in which the pattern should be found. Okay, that's the way. So let's use that. Substituted string, let it be okay, string equal to pattern dot sub of dot, let's use 1 3. This actually means the thing that we need to replace over here. So the one means the first term over here and the second term over here. So in between that two terms we need to keep them, right? So let it be the same, and in between that there should be space. That's what we need to print, and it should be decoded string. So this is the pattern that we need to substitute with and the decoded string. So let's print it out. Print substitute. Let's run the code. Okay, what happened over here? Substituted string is not defined. Why it is not defined? I think some spelling mistake. Let it be a string, so that okay, what happened over here? We got the output, but we forgot to change the print statement over here. So let's remove it. Let's run the code again. Okay, we got the output correct. Let's submit the code. Okay, we got the entire test cases correct too. Okay, but we can still simplify the code. Okay, so for doing the pattern, this method substitution dot sub of pattern, then the thing that we need to replace, then the string that we need to check. So it was like that. So we can do that in the same format, like without doing any print of array dot sub, then the pattern. This is the pattern that we need to find. So let's copy the pattern, then comma what we need to replace with the patterns. So just copy that out, then comma the decoded string, the string in which the pattern should be found and replaced. So let's paste that too. Then let's comment it out. Let's try it out. Okay, we still got the same output. So that's the difference. Like we combine those statements together, that's all, instead of like writing it separately like that. And for the next method, in which we find that is not the alphanumeric characters. So in order to do that, let me just copy the terms first. This is the decoded output. So what we need to find is that we need to find the elements that are not alphanumeric characters in this term. So in order to do that, we only need to change the patterns. So here the pattern will be like, if we are doing this way, we don't need to keep the first and third term here. So let's rub it out and just place a space over there, as we only need to replace everything with space, as we are directly finding these two over here. So we don't need to keep the first and third starting and ending terms here. So just space is enough, and we can just remove this part. Then what we can do is, like, we are finding characters that are not alphanumeric characters. So let's define alphanumeric characters first. That will be like A to Z, then capital A to Z, then 0 to 9. So these are the alphanumeric characters. So if we need to find something that is not anything, we have to use this command. When we are using inside a square bracket, it means that return a match for any character except ARN, as ARN is mentioned over here. And if we start with this symbol, it means that it will not return anything with this one. So instead of here, we are using alphanumeric characters. So if we start with this symbol, it means it will return things that are not alphanumeric. And actually there is another use for that symbol. Okay, if we use that symbol, then we can search for starts with. But if it is inside a square bracket, it means things are not that are not that things. Like if we add a square bracket here and here, then it means it will print return elements that are not HELLO. So the letters except these things, though it will be like that. So we can use that symbol along with that, yeah, that symbol. Then we need to do one more thing, that is we need to check whether it's after the starting or ending of words. So in order to find that, there is another character that we need to use. This is /b, returns a character where the specified characters are at the beginning or end of the word. So R in the beginning is making sure that the string is treated as a raw string. Okay, let's try it out. So this is for the ending part. So if AIN is present at the end of the word, it will print here exists. Yes, there is a match. So AIN is here. The rain in Spain. So AIN for the rain and Spain AIN. So both of them have been found as a match. So similarly, we need to find for the alphanum symbols, right? Likewise here, we need to find for we are checking for non-alphanumeric characters that are at the end or starting of a string. So this is going to be starting of a string, starting of alphanumeric characters, and this is end of alphanumeric characters. So we need to use that in the starting as well as ending, so that we will get that. And we don't need to we need to check not only for a single alphanumeric character, we need to check for more than one alphanumeric character. So we need to add a plus over here, so that it will print all the elements that are not alphanumeric. This means not alphanumeric, that are more than one, as well as, so if there is only one I over here, it will print it as a wrong. So if is there, it will still find that and print the elements like characters that are not alphanumeric. So that's what we need to find over here. So let's print out. So we'll get the same output. Like it's just the same thing, but we are doing it in two ways. In the first way, we directly find this pattern, and we directly found out that pattern. But in the second method, we are finding those finding the things that we need, and we are finding the things that we don't need, like the things we need minus the total, like that. So in the second method, we are actually finding, suppose if we need a portion from the total minus the portion that we need equal to the portion that we don't need. This is what we did in the second method, but in the first method we directly found out the portion that we don't need. So this we did in the first method over here, and this is the thing that we are doing in the second term. Like the we will be finding the things that we need first, and it will be removed from the total. So that's the second method. So that's it for today. I think the video is helpful to you guys. If you find this video helpful, please like and subscribe to my channel. Tomorrow we can meet with the 14th day problem. So it's we got the test cases correct too for the second method. Both of them works fine. So you can do it with any of these methods. Okay, that's it for today. We can come with tomorrow. I will be sharing the links of this in the description too. Okay, that's it.